Hi everybody, and welcome to the second video on vectors. In this video we will just continue the trajectory of study that we began in the last video, and in particular here are three things with vectors that I want to show you how to do. I'm going to show you how to sort a vector, so arrange the entries from smallest to biggest or from biggest to smallest. I'm going to show you how to search a vector for a particular entry. So suppose that you have a list of numbers and you want to know if 10 is an entry in that list. I will show you how to do that. And I will show you how to erase entries from a vector. So by the end of this video, you will be able to search a vector for the number 10 and erase it if you want to. Okay, so let's start with sorting. Suppose you want to take the entries of a vector with numbers in it, right? This doesn't really apply to characters really. And you want to sort the entries from smallest to largest. It's pretty easy to do that using the algorithm library. So you're going to need to do this hashtag include guy to plug into this algorithm library. Once you have done that, sorting a vector is just this single command, sort. Okay, so this will sort from smallest to biggest. Now, if you weren't going to use this, I think all of you could think through how to sort a vector on your own. You know, how to take a jumbled list of numbers and make sure that the smallest appears at the beginning and the biggest appears at the end. But it is a very non-trivial exercise to do that. So if I gave it to you as a homework problem, it would be probably the hardest homework problem you've had so far this semester. So anyway, I decided it wasn't worth the effort to think through how that algorithm goes. So we're just going to use this single command. So this sort command goes from smallest to biggest. If you want to go from biggest to smallest, the first thing you do is you sort from smallest to biggest, and then you use this reverse command, which also takes advantage of this algorithm library. And all that does is it reverses the order of the list. So what was first is now last, what was second to last is now second, and so on. Okay, so that's easy enough, so let's just confirm that works. So let's just sort this guy here. I already have a vector going. Let's sort my vec from smallest to biggest. Okay, so just to confirm that that worked, let's just print the vector to the screen using the for loop that we talked about in the last video. So anytime you want to print a vector, this for loop will do it for you. You always start at position 0 and go up to the size of the vector -1. So let's just see out my vec at position I, and let's put a new line in between. So just notice right here that this list is not sorted originally, right? It sort of jumps all over the place. But if I run this, oops, okay. If I run this, notice it goes from smallest to biggest, right? If I wanted to go from biggest to smallest, I just do the same thing, but after sorting, I reverse it. And now if I print, it should go from biggest to smallest. And that's what it does. Okay, so if you plug into the algorithm library, sorting a list is easy. It's just, if you want from smallest to biggest, it's this command. If you want from biggest to smallest, it's these two commands. Okay, so now let's move on to finding a particular value. So here's just a play example here, right? You have an integer vector and you want to know if 1 is an entry or not. So I'm going to show you the code in a second, but the logic here is just, well, just go through the vector one by one, right? Go through the entries one by one and see if you see a 1 or not, right? And just record if you do. That's the logic, right? Just march through the entries, and if you see a 1, record that somehow. So here's sort of a fast and cheap way to do that. This little x variable here will be the variable that we will use to record whether or not we got a hit. So this for loop here is just going to march through the entries of the vector one by one, right, position by position. If we ever find a 1, right, if my vec at some position is 1, then we change the value of x. And it doesn't matter what you change the value to, right? You could change the value of x from 0 to 35. It doesn't matter. What matters is that you change the value to something, and then once the loop is done, whatever that value is, If x now is that new value, in this case 1, then we're just going to say, oh, we found a 1, right? Because if you ever find a 1, you will enter this if statement and the value of x will change. If you never found a 1, that means that you never entered this if statement and the value of x never changed. Therefore, if x equals 1, you see out this. Otherwise, you know that you didn't find a 1. So let's just see how that goes in this vector here. Let me go ahead and comment out these sorting things. I don't care about them anymore. So let's have an integer value 0, and let's just march through the vector entry by entry. Dot size. Okay, and so if we ever find, and let's search for the value 1. Why not, right? If we ever find a 1, let's change the value of x to whatever, right? To 1. Doesn't matter. Okay, so now after this is done, we can tell the user, like, oops, if x is now 1, that means we got a hit, and so we can say, we found a 1. But otherwise, we know we didn't find a 1. So let's just run this. Let me put in a new line in between all this so everything is clear. So let's run this. Okay, so notice it says we didn't find a 1, right? And then it printed out the vector beneath. But what matters is that this code worked here, right? There is no 1 inside this vector. Right? Remember, this is the vector down here. 3, -5, 15, -1, etc. There is no 1. Therefore, we never went into this if statement, so the value of x never changed. So we go into this this else statement here. But inside of this list, there is a 17, right? So let's just see if this code works with 17. Oops. So let's march through one by one, and if we find a 17, we'll change the value of x from 0 to 1. And now we want to tell the user whether or not we found a 17. Right? And notice, it tells you now, oh, I found one, right? That's because at some point in this list, right, at some position there was a 17, so therefore the value of x changed. So anyway, here's a quick and dirty way of searching a vector for a particular number. You just have this dummy variable whose only role is to change value if you get a hit. And as long as you keep track of like what that value change is, right, you know that x goes from 0 to 1 or from 0 to 30 or whatever. As long as you know what that is, you can keep track of whether or not you got a hit. Okay, so here's the code over here that does that for you, right? Before we move on, though, I want to point out that sometimes you don't just care if you found a hit, right? You don't care just that you found a 17. Sometimes you want to know where was the first 17, right? At what position was the first occurrence of a 17? So, in other words, you want a find function like the string find function. So remember how that worked. What that function did was it found the position of the first thing you were looking for. So if you were looking for the word bad, even if there are millions of bads inside the sentence, the function is only going to find the first instance of that word. So let's think about how you could do that here. You know, if you want to find the first instance of 17, you want to know 4, right? In this particular list, you don't want to know 7. So how could you not only know whether or not there's a 17, but know where the first occurrence is? Well, let me show you a trick to do that. Let me just change this initial value from 0 to -1. The reason is because 0 actually is a legitimate position. So here, just fill in a number that can't be a position inside of a string. So any negative number is fine. So now what happens here is, let's just say that as we go through the loop, let's not change the value of x from -1 to 1. Let's change the value of x from -1 to a position. Right? I is keeping track of position. So now what's going to happen is, if you get a hit, x will record the position where you got that hit. And so now down here we can say, if you have a number now that's bigger than -1 for x, that means you got a hit. So we found a 17, and let's actually say where we found it, at position x. Otherwise we didn't find a 17. Let's run this now and see what it does. It says we found a 17 at position 7. Okay, so we've made progress here because there is a 17 at position 7, right? So this code we've written will tell you a position where this number occurs, okay? The only problem is that we wanted the first occurrence of 17, not the last occurrence. So notice this for loop here, it just keeps running. It keeps running until it gets to the end of the vector. But you don't want it to do that. What you want to have happen is you want to go through the vector entry by entry by entry, and the first time you see a 17, if that's what you're looking for, you want to break out of the loop and record that position where you found it. So you want to just go like position 0, is that 17? Oh no. Position 1, is that 17? No. Position 2, 17? No. Position 3, 17? No. Position 4, 17? Ah yes, right? And then immediately stop looking anymore, right? There's no reason to keep going through the loop entry by entry because you found what you were looking for. And unfortunately, this for loop as constructed won't do that for you. This will keep going until the end of the vector. So let me just show you a cute little cheat to get around that. Let's now have this loop run up until the end of the vector, but the other condition that must be satisfied to keep running is that the value of x is still -1. So what's going to happen here is, as long as the value of x is -1, the loop is going to keep going. But if the value of x ever changes from -1 to something else, the first time that happens, we're going to break out of this loop. Okay, so adding this condition here to your Boolean statement means that you can break out of the loop earlier. So this condition must be satisfied to keep going, and also this condition must be satisfied to keep going. So as soon as this condition here fails, you'll break out of this loop. So let's run this now and see what happens. It says we found a 17 at position 4 now, right? And again, that's what we wanted, position 4, the first occurrence of a 17. And the reason it works the way we want it to now is this loop goes entry by entry, right? Starts at position 0, then position 1, then position 2. The first time it finds a 17, the first time you get a hit, it changes the value of x from -1 to whatever that position is. But now the value of x is not -1. That makes this statement false, and therefore you break out of the loop. So this gives you a way of breaking out of a loop early if you need to. Okay, so not only can you find a particular number, you can know where it occurs if you want to. The first time it occurs, if you want to. Okay, so the last thing I want to show you is erasing an entry from a vector. And again, you might think through how you could do this on your own without plugging into a built-in function, but I decided that was not worth our time, so here's how you do it. If you want to delete the entry at position I from myvec, the command is simple. You do myvec.erase, appropriately enough, yes. And then you do myvec.begin. And then this is sort of confusing, but this is just the syntax, plus the position. That will erase the entry from the corresponding position. So let's just say that I want to erase, so myvec.erase. Okay, so myvec.begin, and let's say I want to erase the entry from position 2. And remember, since we're starting to count from 0, that means the third entry, right? So this number here is the position inside of the vector. Okay, so if this code works the way I say it works, this 15 should be gone because I'm erasing the entry from position 2. And now when I run this for loop here that prints the vector to the screen, 15 should be gone. And notice that it is, right? So if you know a place that you want to erase an entry from, it's easy enough to do. It's a single command. So I'm going to show you an example of why this is useful here in a second, but let me just give you I mean, you might be wondering, right? Like, what does it matter if I can sort and that I can erase and things like this? I mean, what does it matter that I can sort from biggest to smallest, right? Let me just give you one example of how I use it. I calculate your grades using a C++ program that I wrote because I feel that's appropriate for this course rather than using Excel, right? So normally I would use Excel, but to stay in the spirit of this course, C++ will grade you. But the thing is, I drop your lowest homework score. So if you want to drop a homework score, it seems to me the easiest way to do that is to store all of your homework scores as a list, as a vector. And once I have that list, I sort it from biggest to smallest. And then I can use the popback function, which we introduced last time, to kick off the last entry, which is now the lowest entry. Okay, so let's just see how that works. So let's just say that, let me get rid of all of this now. Let's just say that these are your homework scores. Okay, so you did okay on 3 of them, and on 1 of them you offended me so badly that you got a -5. Okay, so let's say these are your 7 homework scores. Suppose that before I compute your average score, I want to drop your lowest score. It seems to me that the easiest thing to do is just to sort from biggest to smallest, which is what these 2 lines of code will do, and then just use the popback function from the previous video, right? That will now kick the last entry off. Now the vector consists of all of the entries except for the lowest score. So let's just print out the entries again and see what happens. So notice the scores have been sorted from biggest to smallest, and that -5 is now gone. Okay, so there's one use of these things. There are many other uses, and you will see them throughout your homework and group project and so on. Okay, so I want to end this video by putting all this together, and let's just think about using this in the context of that game Deal or No Deal. So if you've never seen this or you don't remember the rules, it's the game with the least amount of skill ever, I suppose. It's just sort of a classic casino game where it feels like you have some control, but you don't. But anyway, there are 26 pretty hot women holding 26 briefcases, and each briefcase is labeled with a number, 1 through 26. And there are money values inside the cases. And so what happens is the player chooses 1 briefcase at a time, or sometimes they choose like 5 at a time, but it doesn't really matter. So for now, let's just say 1 at a time. And that case gets removed. So the number that's on the case gets removed from the game. So suppose you want to write a computer program that lets people play this game. Well, it seems like the thing to do is to start with a vector consisting of these 26 numbers, right? And then based on the number that the user chooses, you kick that number out of the vector and just keep going, right, until the player decides to stop. So you start with this list here, and then if the player chooses the number 15, you kick the number 15 out, and then if they next choose the number 12, you kick 12 out, and so on. So let's just, we're not going to write a full, deal or no deal program, but let's just see how that might work. Okay, so at the beginning, we have a vector of size 26 cases. Okay, and so let's just cases. So this loop here will still print the entries, but let's start by just giving the vector its values. So we're going to go 1 up to 26. I less than. So cases at position I is actually going to be I plus 1. Okay, so if you think about it, at position 0 we want case 1, right? At position 1 we want case 2, etc. So the cases are sort of one off from the actual position. So now if I do nothing else, I can run this and it will print the numbers 1 through 26, right? Those are the original cases. So let's give the user a way to pick a number that we're going to kick out. So what case do you pick? And we get that from them. Okay, so now what we want to do is we want to find this guy inside of the list, record its position, and then kick it out. So let's just do the find first position thing here that we did before. So let's go through the vector. So I equals 0 up to the end. And here, since all of the numbers are distinct, we don't have to worry about finding the first occurrence. So I'm not going to worry about that right now. The numbers in this vector are all different. So, oops, sorry. Before I need to have my my cases up here before I start searching for anything. But anyway, the numbers are all distinct, so you don't have to worry about repetitions, so you don't have to worry about that and trick that I did before. Okay, so now if we find cases is that number that they gave us, we're going to save that position. Okay, so now what will happen is we have a recording of where that case is that they chose. So now let's just erase it. So let's do, well, what's the code? Cases.erase, and now cases.begin, and we add that position that we found. So that's the syntax. And now we'll print out the cases that are left. So what case do I pick? I picked case 10, right? Lucky 10. Now it prints the list, right? But notice 10 is gone because you kicked it out, right? So if you want to think about writing a complete deal or no deal program, essentially all you do is you just keep doing this in a loop, right? Because you let the user keep going. And every time you get a number from them that they pick, you erase the number they chose and then keep going. So if you put all of these things together, it allows you to keep track of information while deleting information you don't need anymore. Right? So we start with a full list of information, which is all 26 cases. And then as the user keeps throwing cases out, you can record what they're throwing out. And you now have a vector that has only the remaining briefcases in that vector. Okay, so there's one use of this, but use your imagination and you can think of thousands of uses of this. So that's the end of this video.